Non-relational data services. In this unit, you'll learn more about what the provisioning process entails and what actually happens when you provision a service. So what is provisioning? Provisioning is just the process of setting up IT resources. It can also refer to the steps required to manage access to data and resources and make them available to users and systems. It's basically just running a series of tasks to configure a service. Provisioning is not the same as configuration, but they are both steps in the deployment process. So when we say spin up a Cosmos DB, there's much more going on behind the scenes. We have to provision various resources to run the service. These resources, such as disks, memory, CPU, and network settings, are needed to run the service efficiently. These resources will be assigned to you, allocated to you, which means charged to you. So much like a car, you aren't concerned about what goes on under the hood. You just tell Azure how much horsepower you need and leave it all up to them. Azure provides several tools you can use to provision service. One of these are the Azure Portal. The Azure Portal is the most convenient way to provision a service for most users. A graphical user interface makes it possible for all your users, even some who aren't overly tech savvy, to be able to provision resources easily. The Azure Portal displays a series of service-specific pages that prompt you to provide details about the resources you are provisioning and validates these settings before actually provisioning the service. Next, the Azure command line. The Azure command line provides a set of commands that you can run from the operating system command prompt or the Cloud Shell in the Azure Portal. I gave it a try a while back and I was really impressed. It got a very simple, easily discoverable syntax, and it has the benefit of being cross-platform. Another great thing about it is that there's an Azure CLI console built right into the Azure Portal, so you don't even have to install it to give it a try. You can create and manage resources via the command line, just as you can in the portal, and it's great for the automation of service creation, because we can just store command line commands in scripts that we can run on demand or on schedule. This command line can run on Windows, Mac OS, and Linux computers. Another way to provision resources in Azure is the Azure PowerShell. Windows administrators are very familiar with using PowerShell commands to script and automate administrative tasks. Azure PowerShell is basically an extension of Windows PowerShell. It lets Windows PowerShell users control Azure's robust functionality. From the command line, Azure PowerShell programmers use preset scripts called commandlets to perform complex tasks like provisioning virtual machines or creating and managing cloud services. Azure PowerShell is available for Windows, Mac OS, and Linux. The Azure Resource Manager. So Azure Resource Manager templates are used to deploy services via text. This is referred to as infrastructure as code. The JSON file describes the service or services that we want to deploy in a text file. So you send the template to Azure using the AZ deployment group create command in the Azure command line, or by using the new -AZ resource group deployment command in Azure PowerShell. Configuring non-relational data services. So once the resource is provisioned, it's time to configure. We need to configure these resources to meet the needs of our application. We may need to add network connectivity or make changes to the firewall. For example, when we create a Cosmos database, the default connectivity is to enable access that's wide open to the world. You can connect to these services from an on-premise network, the internet, or from within an Azure virtual network. This may be great for a web server, but we may want to configure some changes to this setup and maybe only allow access from our own IP, for example. Let's look at how we can configure connectivity to virtual networks and on-premise computers. So to restrict connectivity, always go to the Firewalls and Virtual Networks page for a service. To limit connectivity, choose Selected Networks. 3 further sections will appear labeled Exceptions, Firewall, and Virtual Network. The Exceptions setting allows you to enable access to any other of your services created in your Azure subscription. It essentially creates an exception to the rule for a specific Azure service. If you need to connect the service from your Office PC or from an on-premise server, in the Firewall section, add the IP address of the computer you're using. This opens up the firewall to only your IP address. In the Virtual Network section, you can specify which virtual networks are allowed to route traffic to the service. When you create items like web applications and virtual machines, you can add them to the virtual network. If these applications and virtual machines require access to your resource, add the virtual network containing these items to the list of allowed networks. You may have a web server that needs access to a storage service to upload photos. Here is where you need to add the virtual network that holds the storage resources to be able to connect to your web app and virtual machines. Let's look at configuring connectivity from private endpoints. So it's very important to secure all aspects of your application, including your data communications. This can be difficult as services in the cloud are often exposed to the public internet. Using Azure Private Endpoint, you're using a private IP address from your VNet, and that can help to secure traffic between Azure services and other applications. You can use Azure Private Link to secure Azure services and also your own services. Consumers of services that are protected with Private Link can simply use the private link and communicate with protected services directly over the Azure backbone instead of over the public internet. The Private Endpoint Connections page for a service allows you to specify which private endpoints are permitted to allow access to your service. You can use the settings on this page together with the Firewalls and Virtual Networks page to completely lock down users and applications from accessing public endpoints to connect to your Cosmos DB account. Configuring authentication. So many services include an access key that you specify when you attempt to connect to a service. So for an Azure storage account, you allow access keys under Settings on the main page for the account. Azure Service actually provides 2 keys, Key 1 and Key 2. You can choose whatever key you want, it doesn't matter. Any user or application who knows the access key for a resource can connect to that resource. So as a result, access keys provide a rather coarse-grained level of authentication. If an authorization rule is just based on one particular check, like a key, then it's considered coarse. Additionally, you need to regenerate an access key, say after an accidental disclosure, and you may need to update all applications that connect using that key. Azure Active Directory provides superior security and ease of use over access key authorization. Microsoft recommends using Azure AD authorization when possible to minimize potential security vulnerabilities when using access keys. Azure Active Directory is a fully managed multi-tenant service from Microsoft that offers these identity and access capabilities for your applications running in Microsoft Azure and for applications running in on-premise environments. Configuring access control. So role-based access control is a method of establishing and controlling user access rights based on a user's competency, authority, or responsibility within the organization. This relates to the access the user has to perform specific tasks such as read, write, modify, etc. Access management for cloud resources is a critical function for any organization that's using the cloud. Azure Role-Based Access Control, or Azure RBAC, helps you manage who has access to Azure resources and what they can do with those resources. For example, using RBAC, You could manage accessibility to specific services just needed to complete one's job. You can allow a user to manage all resources in a resource group, such as virtual machines, websites, and subnets. You can allow a database administrator group to manage SQL databases in a subscription, or you can allow an application to access all resources in a resource group. Azure RBAC role assignments. You can control access to resources using Azure role-based access control to create resource role assignments. A role assignment has three elements: a security principal, a role definition, and a scope. So the security principal is the who. A security principal is just a fancy name for a user, group, or application that you want to grant access to. The role definition is what you can do. So a role definition is a collection of permissions. It's sometimes just called a role. A role definition lists the permissions that can be performed, such as read, write, and delete. Roles can be high level, like owner, or specific, like virtual machine contributor. And the scope. The scope is the where. Scope is where the access applies to. This is helpful if you want to make someone a website contributor, but say only for one resource group. In Azure, you can specify a scope at multiple levels: management group, subscription, resource group, or just resource. Scopes are structured in a parent-child relationship. When you grant access at a parent scope, those permissions are inherited by all the child scopes. You add role assignments to a resource in the Azure portal using the Access Control IAM page. The Role Assignments tab enables you to associate a role with a security principal, defining the level of access the role has to the resource. Configuring advanced security. So apart from authentication and authorization, many services provide additional protection through advanced security. Advanced security implements assessment and threat protection. Assessment identifies possible security exposures and recommends actions to fix them, while threat protection adds security intelligence to your service. Azure monitors user, device, or resource behavior in order to create a baseline for comparison. Then it detects any anomalies through adaptive built-in intelligence. This gives you insight into your network traffic so you can identify and quickly respond to any potential threats. You are charged an additional fee for this very good feature that can really tighten up your application and make you aware of any suspicious behavior as soon as it begins to happen. Now let's discuss how to provision other non-relational data services. So besides Cosmos DB, Azure supports other non-relational data services. These services are optimized for more specific cases than a generalized document database store. The first of these is the Azure Blob storage. This allows users to store large amounts of unstructured data on Microsoft's data storage platform. In this case, Blob stands for Binary Large Object, which includes objects such as images and multimedia files. These are known as unstructured data because they don't follow any particular data model. Next, we have the Azure Data Lake storage. This is a repository for large quantities and varieties of both structured and unstructured data in their native formats. And finally, Azure File Storage. This is a shared storage service that lets you access files via the Server Message Block, or SMB protocol. And you can mount these file shares on Windows, Linux, or Mac machines in the Azure cloud. As with Cosmos DB, we can provision these services using the Azure portal, the Azure command line interface, Azure PowerShell, and Azure Resource Manager templates. Data Lake storage, Blob storage, and file storage all require that you first create an Azure storage account. Creating a storage account in Azure portal. So once we're in the Azure portal and on the Basics tab, we'll see a lot of options we can choose from. The first one being subscription. So here's where you select your Azure subscription. From there, we see resource group. So a resource group is just a way to group resources that share the same lifecycle and permissions. So here you select an existing resource group or create a new one. Next, you'll see storage account name. Same as Cosmos DB accounts, each storage account must have a unique name that hasn't already been used by someone else, so it must be globally unique. You'll see location. So select the region that's nearest to you if you're in the process of developing your application, or if you're deploying your application, deploy it in the region nearest to your users. And finally, performance. This setting has two options. You get standard performance. These are standard storage accounts and they're based on hard disks. They're the lowest cost of the two storage options, but have higher latency. This type of storage account is suitable for applications that need bulk storage that's accessed infrequently. You also have premium storage. These use solid-state drives, have much lower latency, and better read-write performance. Solid-state drives are best used for, say, input-output intensive applications such as databases. You can also use premium storage to hold Azure Virtual Machine disks. A premium storage account is more expensive than a standard account. Please note that the data lake storage is only available with a standard storage account. So the data lakes are using hard disks to store all the data that you're putting into the data lake. You can also create storage accounts using the Azure command line interface by running the AZ storage account command. This will enable you to create a new storage account. There are many SKUs that you can choose from, which are just a combination of performance tiers and replication options. So performance tiers being premium or standard, and replication options being local redundant storage, zone redundant storage, or global redundant storage. So speaking about zone redundant storage, this replication format duplicates your data synchronously across 3 storage clusters in a single region, with each cluster physically separated from the others and in its own availability zone. This allows the data to still be retrieved if one zone goes down. Provisioning data lake storage. One thing to note is that you can't configure data lake storage after the account has been set up. So if you're provisioning a data lake storage, you must specify the appropriate configuration settings when you create the storage account. In the Azure portal, go on the Advanced tab of the Create Storage Account page. In the Data Lake Storage Gen 2 section, you'll see an option called Hierarchical Namespace. Go ahead and enable that. You can also use the Azure command line. Run the AZ Storage Account command with the Enable Hierarchical Namespace parameter to create a new storage account that supports data lake storage. We can also use the Azure PowerShell. By using the new -az storage commandlet with the Enable Hierarchical Namespace parameter, we can provision our data lake storage directly from Azure PowerShell. Once our storage account is created, now we need to go about provisioning blob storage in that storage account. So blobs are stored in containers, and you can create containers after you've created your storage account. In the Azure portal, you can add a container using the features on the overview page of your storage account. Applications can upload blobs, so containers page enables us to create and manage these containers. Each container must have a unique name, and you can specify the access level to the blob. By default, data held in a container is only accessible by the container owner. But by being able to set this access level to the blob, we can enable public read access to any blobs created in the container. Containers also allow role-based access. So we can assign role-based access control for a blob if we need more granularity level of security. If we want to use the Azure command line to provision blob storage, all we have to do is run the AZ storage container create command to establish a new blob container in the storage account. We can also use Azure PowerShell. So using the new -az storage container commandlet, we can add a container to our storage account. First, we must retrieve a storage account object with the get-az storage account commandlet. So that's pulling back our storage account information and firing up a new storage container inside of our storage account. Now let's discuss provisioning file storage in a storage account. So we can provision file storage in one of three ways. The first being the Azure portal. So we provision file storage by creating one or more file shares in the storage account. We can also use the Azure command line interface. We can take advantage of the AZ storage share create command to create a new file share in a storage account. And we also have the option of using Azure PowerShell, where we can use the new -az storage share commandlet, and that will create a new file share in a storage account for us as well. So we have three options, and I'd advise you to choose the one that best suits your needs and your skill level. Azure Table Storage. Azure Table Storage is intended for the storage of large amounts of structured, NoSQL data. Tables are just containers of rows of data. Azure Table Storage provides a key attribute store with a schemaless design. This schemaless feature makes it easy to adapt to any application and data changes. This type of storage is also cost-effective and typically lower in cost than relational database solutions. Another advantage of this schemaless design is that your data is stored such that it doesn't require complex joins, foreign keys, or stored procedures, and that can be denormalized for fast access. We can use clustered indexes to quickly query our data, and we can also query and update our data using the OData protocol. This is a REST-based protocol which allows us to manage our data via APIs. Let's discuss some concepts of table storage, starting with accounts. All access to Azure storage is done through a storage account, so you must create a storage account. Tables is just a collection of entities. Tables don't enforce a schema on entities, which means a single table can contain entities that have different sets of properties. Speaking of entities, an entity is a set of properties similar to a database row. An entity in Azure storage can be up to 1 megabyte in size. An entity in Azure Cosmos DB can be up to 2 megabytes in size. We also have the URL format. So Azure Table Storage accounts use this format, http:// your storage account name .table.core.windows.net and then / your table name. And finally, properties. A property is a name value pair. Each entity can include up to 252 properties to store data. Each entity also has 3 system properties that specify a partition key, a row key, and a timestamp. Entities with the same partition key can be queried more quickly and inserted, updated in atomic operations. An entity's row key is its unique identifier within a partition. The table service data model. Understanding this table service data model is important. The table service offers structured storage in the form of tables. One thing we know for certain is that we need a storage account. A storage account is a globally unique entity within the storage system. The storage account is the parent namespace for the table service and is used as the basis for authorization. You can create an unlimited number of tables, given that each table is uniquely named. The storage account must always be specified in the request URI. So it would be https:// my account name, whatever you call your account, .table.core.windows.net. Azure Table Storage System properties. So the partition key property. In order to load balance across multiple storage nodes, tables need to be partitioned. A table's entities are organized by partitions. A partition is a consecutive range of entities that share the same partition key value. The partition key is a unique identifier for a partition within a given table, specified by this partition key property. The partition key also makes up the first part of an entity's primary key. You must include the partition key property in every insert, update, and delete operation. Next, we have the row key. So as we just mentioned, the partition key is the first part of the primary key. The second part of the primary key is the row key, specified by the row key property. The row key is a unique identifier for an entity within a given partition. So together with the partition key, the row key will help uniquely identify every entity within a table. You must also include the row key property in every insert, update, and delete operation. Finally, we have the timestamp property. This is a date-time value that's maintained on the server side to record each time an entity was last modified. The value of the timestamp property for an entity advances each time the entity is modified and changed. This property should not be set on insert or update operations. This is not a property we set, and if you do, the value will be ignored because the system sets this value. Now let's discuss Azure Blob Storage. Azure Blob Storage is Microsoft's object storage solution for the cloud. Blob Storage is optimized for storing massive amounts of unstructured data, so data that doesn't adhere to a particular data model or definition, such as text or binary data. Blob Storage is designed for serving images or documents directly to a browser, storing files for distributed access, streaming video and audio, writing to log files, storing data for backups and analysis, or for disaster recovery. So how do we access data in Azure Blob Storage? Objects in Blob Storage are accessible via Azure PowerShell, the Azure Command Line Interface, the Azure Storage REST API, and the Azure Storage Client Library. The client libraries that are available are .NET, Java, Node.js, Python, Go, PHP, and Ruby. The Azure Data Lake Storage Generation 2. Blob Storage supports Azure Data Lake Storage Gen 2. This is Microsoft's cloud-based enterprise big data analytics solution. Azure Data Lake Storage Gen 2 offers a hierarchical file system and incorporates many of the advantages of Blob Storage. One of these is high availability. So, local redundant storage replicates your data 3 times within a single physical location. Zone redundant storage replicates your storage data synchronously across 3 Azure availability zones in the primary region. It also takes advantage of strong consistency. So a strong consistency model guarantees that after the service performs an insert or an update operation, subsequent read operations return the latest update. It offers us low-cost tiered storage and disaster recovery capabilities, which goes hand in hand with redundant storage options we discussed earlier regarding availability. Azure Storage offers 2 options for copying your data to a secondary region, which is great for disaster recovery needs. These options are geo-redundant storage and geo-zone redundant storage. Azure Blob Storage Resources. Blob Storage offers 3 types of resources: a storage account, a container in the storage account, and a blob in the container. So a storage account provides a unique namespace in Azure for your data. Every object you store in Azure Storage has an address that includes your unique account name. The combination of the account name and the Azure Storage Blob endpoint forms the base address for the objects in your storage account. Containers organize a set of blobs, similar to a directory in a file system. A storage account can include an unlimited number of containers, and a container can store an unlimited number of blobs. And again, these blobs are anything from text files to image files, audio files, right? It's just blob storage, object storage in this case. So how can we migrate data to blob storage? Luckily for us, there's quite a few options that exist. First of all, the AZ copy is the easy-to-use command line tool for Windows and Linux that copies data to and from blob storage across containers or across storage accounts. We can also use the Azure Storage Data Movement Library. This is a .NET library used for moving data between Azure storage services. In fact, the AZ copy utility is built with the Data Movement Library. And finally, the Azure Data Factory. That supports copying data to and from blob storage by using the account key, a shared access signature, a service principal, or managed identities for Azure resources. So there's many ways that we can get our data to and from blob storage. What if we want to migrate existing data to our blob storage? So a number of solutions exist for migrating our existing data to blob storage in Azure. We can use the Azure Data Box. This is available to transfer on-premise data to blob storage when large data sets or network constraints make it hard to upload data over the internet. This could be massive amounts of data. It's just unrealistic to be able to upload it. We can also use the Azure Import-Export service. That's a good way to import or export large amounts of data to and from your storage account using hard drives that you provide. And finally, Blob Fuse. This is a virtual file system driver that's used for Azure Blob storage. You can use Blob Fuse to access your existing Blob data in your storage account through a Linux file system. Let's discuss Azure Blob storage types. So, Blob storage is a suitable repository for holding large binary objects such as images, video, and audio files. Azure currently supports 3 different types of blobs: block blobs, page blobs, and append blobs. You typically use block blobs best for static data, and they're the most appropriate type of storage for holding the image data. Right? They store text in binary. Block blobs are made up of blocks of data that can be managed individually. Page blobs, great for storing random access files up to 8 terabytes in size. Page blobs store virtual hard drive files and serve as disks for Azure virtual machines. And finally, append blobs. So append blobs are suitable for storing data that grows in chunks, such as logs or other archive data. Let's look at how to create an Azure storage container. So using the Azure portal, if you go to the overview page of your storage account, select Containers. On the Containers page, select the plus next to Container and provide a name for your new container. You can also specify the access level, whether you want it to be public access or not. For a container that will be used to hold blobs, the most appropriate access level is Blob. This setting supports anonymous read-only access for blobs. You can also use the Azure command line if you prefer. The AZ storage container create command creates a new container. This command takes a number of optional parameters, and then you find the full details on the AZ storage container create page in any of the Azure documentation for the Azure command line interface. We can always use Azure PowerShell as well. Using the new -az storage container commandlet is the same as if we use the AZ storage container create command in the command line. So it depends on what you prefer. So now we want to upload a blob to Azure storage. So if you're going to use the Azure portal, go to the page for your storage account select the containers, and on the containers page, select the container you want to use. Once you're ready to go ahead in the portal and select Upload. If you want to use the Azure command line, you can use the AZ Storage Blob Upload command. And if you prefer Azure PowerShell, you can use the Set AZ Storage Blob Content commandlet. So it all does the same thing. It just depends on what your preferred method of putting your data into the Azure storage is. So how do we go about listing the blobs in the container? If we've been granted appropriate access rights, we can view blobs in a container. So if we're using the Azure portal, you go to your page for your storage account and select containers under the Blob service. We can use the command line interface by running the AZ storage blob list command. And we can always use the Azure PowerShell by running the get AZ storage blob commandlet. What if we want to go about downloading a blob from a container? If we're in the Azure portal, we select containers under the Blob service, find the container that's holding our blobs, and go ahead and click download on what we want to download. We can, as always, use the Azure command line interface. We can provide the system with the AZ storage blob download command and specify the container name, the account name, and the file we want to download. We can also do it in batch as well if we wish to batch download a large amount of files at one time. And we can use Azure PowerShell using the get AZ storage blob content command to download our files from the container. We'll have to specify again container name, the account name, the file we want to pull back. How do we go about deleting a blob from a container? Deleting a blob will reclaim resources used in the storage container. But if you've enabled the soft delete option for the storage account, the blob is hidden rather than removed, and you can restore it later. So we can delete a blob using the Azure portal. We select the container, we select the blob, then we select delete on the details page. We can also use the Azure command line interface. We can run the AZ storage blob delete command, and then we provide our parameters, the account name, the container name, and the names of the file we want to remove. We can also delete in batch if we want to delete a large amount of files at one time. And we can delete using the Azure PowerShell. So we can run the remove AZ storage blob commandlet. And again, we would have to provide our account name, the resource group name, container name, and then confirm that we actually want to delete the blob from the container. Suppose we want to remove every blob in the container. We can go about deleting the Azure storage container itself. Once you remove the container, it automatically deletes all the blobs in that container. Now that's something you should be careful about because you can lose all your data. You can do it using the Azure portal. Select the containers under the Blob service, then select delete. In the command line, we can run the AZ storage container delete command. In Azure PowerShell, we can run the remove -AZ storage container commandlet. Let's dig a little deeper into Azure File Storage. What is Azure Files? Azure Files is a fully managed file share service that you can use to create a file share in the cloud. Based on the Server Message Block (SMB) protocol, this enables you to access files remotely or on-premise via APIs through encrypted communications. The SMB file share is available for Windows, Linux, and Mac OS. Azure Files is designed for sharing files, development or debugging tools, and applications that rely on native file systems. Azure Files NFS file shares are accessible from Linux or Mac OS clients if you're in need of an NFS file share. Let's take a look at the Azure File Share protocols. Azure Files offers two protocols for connecting and mounting your Azure file shares: the server message block, otherwise known as SMB, and the network file system, or NFS protocol. Azure Files does not currently support multiple protocol access, so a share can only be one or the other. It can either be SMB or NFS. NFS shares offers a tighter integration with Linux. This is a fully POSIX compliant offer that is a standard across variants of Unix and other Unix-based operating systems. This file storage service scales up to meet your storage needs and can be accessed concurrently by thousands of compute instances. Let's dig into Azure File Storage and SMB shares. So Azure Files shares mounted with SMB offer more Azure Files features and have no Azure Files features restrictions, since SMB shares are generally available. Some of the features that we may see with SMB shares is the fact that there is no feature restrictions. We have access to Azure File Sync. So Azure File Sync allows us to sync our files from on-premise storage up into the cloud using the Azure file system. We have identity-based authentication, right? That allows us to incorporate, say, role-based access control into our file storage. Full backup support with Azure. We have the option to soft delete. So when soft delete for Blobs is enabled for a storage account, Blobs, their versions, and snapshots may be recovered after they're deleted. So this same thing applies to Azure File Storage. Right? These files can take advantage of soft delete, and they're basically hidden instead of actually deleted. And we get encryption in transit and at rest. So we get encryption in transit using SSL or TLS, and we also get encryption at rest while the file is being stored in Azure. And finally, snapshots. Azure File Storage fully supports snapshots, which allows us to go back in time should we need to. So what are some of the uses for Azure Files? Azure File Shares can be used for containerization. So when storing our application data, it's recommended we shouldn't directly store it in our Docker container. Doing that would mean that the lifetime of your data and the lifetime of your container are bound together. And that's going to prevent you from updating to a new version of the container without losing your data. You would obviously want to persist your data, and to do that, you want to store it into an attached volume. Currently, the best suitable option for doing that with Azure container instances is to attach an Azure file share. Once created, the containerized application will have access to the data it needs no matter what instance it's on. We can also use it for lift and shift applications, so for migrating an in-house application to the cloud. Azure Files makes it easy to lift and shift applications that expect a file share to store file application or user data. Azure Files enable both the classic lift and shift, where both the application and its data are moved to the cloud, and the hybrid lift and shift, where the application data is moved to Azure Files and the application continues to run in-house. And we can use it to replace or supplement file servers. So Azure Files can be used to completely replace or supplement our traditional on-premise file servers. Like we mentioned earlier with Azure File Sync, we can push all our server data from on-premise to the cloud very easily. Azure Files can be used to simplify cloud development. So Azure Files can be used in many ways to simplify our cloud development projects. One of them can be diagnostic sharing. So an Azure File Share is a great place for cloud applications to write logs, metrics, any crash dumps, and the like. We can use it for dev, test, and debug. So when developers or administrators are working on VMs in the cloud, they often need a set of tools or utilities. So copying these often used utilities and tools to each VM can take a long time. So if we mount a file share locally on the VMs, the developers and administrators can quickly access their tools, no copying required. And finally, shared application settings. So a common pattern for distributed applications is to have configuration files in a central location. We want to be able to access these from any application instances. So these application instances can load their configuration through the File REST API, and us humans can access them as needed by mounting the SMB share locally. Some of the key benefits of Azure file storage. First of all, familiar programmability. So applications running in Azure can access data in the share via file system I/O APIs. Right? Developers can leverage their existing code and skills to migrate existing applications. It's fully managed, so Azure file shares can be created without the need to manage the hardware. We don't have to go and buy more disks when we want to scale up. Right? It's already done and it's fully managed for us. We have shared access, so it supports SMB and NFS protocols, so we can seamlessly replace our on-premise file shares without worrying about application compatibility. Scripting and tooling. So PowerShell commandlets and Azure command line interface gives us the opportunity to create and mount and manage our file systems as part of the administration of Azure applications. We can do that right from our personal PC. We can do it on-premise. We can even write it in the cloud. And resiliency. So Azure files have been built from the ground to always be available. So once you replace your on-premise file shares with Azure files, you don't have to worry about file sharing going down. You don't have to lose sleep about these things. You don't have to worry about the power going out or the network going down, because this is all going back to being a fully managed service and everything being hosted in Microsoft Azure. And Microsoft Azure is resilient and it's been designed with resiliency in mind. How do we go about managing the Azure file storage? We can use Azure file storage to store shared files. Users can connect to a shared folder. They can create file shares if they have the appropriate permissions. And they can read and write files if they have the appropriate privileges, much the same way as they would use a folder on a local machine. The Azure Storage Explorer. So the Azure Storage Explorer is a utility that enables you to manage Azure storage accounts right from your desktop computer. You can download it from the Azure Storage Explorer page on Microsoft website. And once you get it, you can use Storage Explorer to create blob containers and file shares, as well as upload and download files. A version of this utility is also available in the Azure portal on the overview page for the Azure storage account. Let's discuss uploading and downloading files in Azure File Storage. You can upload and download individual files to and from your Azure File Storage manually by using Storage Explorer, the Azure portal, or by connecting the file share to your desktop computer and dragging and dropping files from File Explorer. However, if you need to transfer a significant number of files in and out of Azure File Storage, you should use the AZ Copy utility. The AZ Copy is a command line utility optimized for transferring large amounts of files or blobs between your local computer and Azure File Storage. It has failure detection. It can restart at the point of failure. You don't have to repeat the entire operation if something fails. Generating short access signature tokens using Azure Portal. So before you can run the AZ copy, you generate a shared access signature token. A shared access signature token provides control, time-limited, anonymous access to services and resources in a storage account. So users don't have to provide any additional credentials. And these SAS tokens are great in situations where you don't know in advance which users will require access to your resources. So you can create an SAS token in the Azure file storage using the portal. On the page for your storage account, under Settings, select Shared Access Signature. On the Shared Access Signature page, under Allowed Services, select File. Under Allowed Resource Types, select Container and Object, and then under Permissions, select Privileges. Assign the privileges that you want to grant to your users. Then set the start and end time for the SAS token. Specify the IP address range of the computers your user will be using, and then select Generate SAS and Connection String to complete the generation of the SAS token. We then copy the value in the SAS token field somewhere safe where it can't be compromised. So let's discuss AZ copy a little more when it comes to uploading files to Azure File Storage. AZ copy is that command line utility that can be used for uploading, deleting, listing, creating files in your Azure File Storage. So it's a command line utility that you use in combination with your SAS token to be able to perform all these operations in your Azure File Storage. So in this course, we've examined non-relational data services. We did this by exploring provisioning and configuring non-relational data services, Azure Table Storage and Azure Blob Storage, and Azure File Storage, including management. In our next course, we'll move on to explore Azure Cosmos DB, including MongoDB, Cassandra API, Table API, and Gremlin API.